Africa Science Dialogue, closing the gap between science and society.
Now, what do you think when you hear about a parasite? You're most probably thinking ticks or some other crawling little things out there. But parasites can be plants as well, you know. And today in studio I have with me Willie Kibet, who deals with, who thinks about predominantly, almost always when he's not thinking about football, about parasitic plants that are very harmful to cereal crops. And these parasitic plants, we've called them cereal killers. He is after the so using biotechnology to try and hunt a serial killer. I know how interesting that sounds, but it's going to sound even more interesting when we bring him into this discussion. Now, who is Willie Kibet? Willie Kibet is a plant biotechnologist from KU, Kenyatta University, whose research focus is on parasitic plants, like I said, using modern biotech tools to confer resistance on cereal crops. He has a strong interest in science communication, outreach, and advocacy with the aim of disseminating importance and potential of modern biotech in providing solutions to challenges of the modern world. And like I said, he's much more. We'll talk about what he likes in football and how it probably, I don't know if we're going to link that with his love for pursuit of serial killers. Nobody loves a serial killer out here. Willie, karibu.
Asante sana.
How is KU?
KU is nice.
Okay.
I've been there this morning.
Okay.
And I can say it's quite good.
Nice.
And we have a lab there, the Plant Transformation Laboratory, level 2, biosafety. And we do some work, some really exciting work there.
Which is what we're about to hear about?
Majorly we focus on parasitic plants. Striga predominantly.
Yes.
And another one, a stem parasite called Cascota.
You know, I was wondering, thinking about parasitic plants, why don't you just let them roam free for biodiversity? Like, I mean, the weeds. Because growing up, we had a notion that not every weed, but most of the weeds can actually be food.
Not really. Weeds, as the word itself says, they depend or fend off from or depend predominantly on important crops, which are a basis of livelihood for many people. A population like Kenya, we are hugely dependent on agricultural produce. So in the angle of parasitic plants, they can be used as models for studying food security. As you understand, food security is an important topic in our country, Kenya, and sub-Saharan Africa as a whole, and also globally. So parasitic plants usually reduce yield of important crops. For example, the common crops that you know, the cereals. Let's say maize, we have sorghum, and we have rice, and others. So parasitic plants, they usually prey upon these cereal crops and siphon off nutrients as well as water. And the end result of this is that this plant will not produce the desired yield. So, which directly impacts or reflects upon the produce and as well as important income. For instance, let's say farmers depend on these crops for income, the smallholder farmers, who are quite a number in our country. So you find these subsistence farmers are affected by low produce. So that's the reason we study these parasitic plants as a way of trying to provide solutions, like real life solutions to these smallholder farmers, mostly at different levels, community levels.
Okay. So from where you come now as a scientist, of course, as a farmer, I want the elimination of this weed completely.
Yes.
I want my maize to thrive. I want my sorghum to do well. I want my whatever to do very well.
Yeah.
But from your viewpoint as a scientist, do you really want to eliminate this weed, like do away with it completely, or are you just trying to remove it from the farm? And how will that eventually affect biodiversity?
So, for instance, so an interesting point you brought in about biodiversity. So you've heard about invasive species. So these parasitic plants, for instance, Striga. Striga is a root parasite that has huge deposits of seeds, normally referred to as seed bank in soil. So these seeds are quite problematic and take years and years. It can take years and years for it to be eradicated. And without proper intervention measures, which we refer to as integrated pest management strategy, these seeds in soil continue to double or even increase exponentially. So without proper management strategies, so some of the common management strategies that farmers use are referred to as conventional. The common ones: uprooting the parasitic plants, intercropping, improving soil fertility. However, these measures are not that effective. That's where we bring in the science. So the science of new technologies, for instance, the likes of genetic engineering, and the the new technologies such as genome editing, which I'm currently working on and interested in. So we are trying to confer some form of resistance towards these parasitic plants, which, as I've mentioned before, they are invasive species. They were not. They were not initially in the areas that we found them. We find them now. They're quite prevalent. For instance, in Western Kenya. I don't know if you have been to Western Kenya, for instance, in areas of Busia, Kisumu, as well as other parts. So this weed, if you go to and have a conversation with the farmers, they just say it's quite a problem. It's a huge problem. At times they usually tell you, please help us. That is service to humanity as a scientist. That's where we come in as a scientist. You feel satisfied that you're doing a good cause. You're trying to help that farmer, not profiteering or anything. You are up after a good cause, because if you help this particular farmer, that farmer will get good yield, and that translates to income. And that income translates to other things such as education, educating their children, good healthcare, and dignity of their lives. So that is the end game. So in a nutshell, these are invasive species. In fact, they're the ones messing with biodiversity.
Okay. Now, before you go to your next point, and I'm sorry to interrupt your train of thought.
Okay.
Now, you have this conventional ways of dealing with, say, Striga or whatever other weed we are dealing with here. In biotechnology, and when you're doing maybe genetic modification, what do you do? Are you eliminating the weed, or are you just building resistance in such a way that the weed will still grow but will not, for the benefit of somebody who has not interacted with this topic at all? What happens?
Great. The classic term here is conferring resistance.
Okay.
So you're trying to confer resistance towards this particular plant. For instance, you are planting sorghum or maize. So you identify this particular maize, usually referred to as farmer preferred. A farmer prefers it because it is high yielding. So that is the basis. So, but this high yielding sorghum plant or maize plant is highly affected or susceptible towards the weed. In this case, you used again the example of Striga. So you're trying to confer some resistance so that this particular crop of that the farmer prefers is not that affected. It's not affected by the weed itself. So what we do in biotechnology, in this particular case, we try to identify some genes referred to as resistant genes, or in another case, we identify susceptible genes. And that's this where the genome editing comes in. So if you identify some susceptible genes, you use genome editing to knock out this particular susceptible gene. When you knock it out, you have eliminated that particular gene that makes this particular crop to be affected or infested by Striga, the weed in the farmer's field. So the end game here, of course, we'll do some tests. And I know there's an issue about biosafety and so on. So in this case of knockout, you're not introducing a foreign gene to this particular crop. So you may ask, is this GM? Nah, it's not GM. So because you have eliminated some genes, there's a deletion in there. So we after doing that, of course, that is done in the laboratory. After doing that, we do some assays to identify if that particular gene has been indeed knocked out or is no longer present. And then we carry on, we do some glasshouse assays or laboratory assays therein. So to identify whether this particular crop, initially, we compared it to the initial one. Initially, it was highly affected by this particular parasite. However, if you do the assays, you compare. If there's some significant differences between the level of infestation of the weed to the initial crop and the newly edited crop referred to as mutants, you say, it is successful. How is it successful? You have the data. Data don't lie. You now say, I have conferred some resistance. Has the yield increased? Okay, good. That is our part. However, you may ask, does this stop there? No, it doesn't. That's why we need to translate this particular research to real life applications. That's why we have the policies as well as regulatory agencies in the country, such as the National Bioscientific Authority. They usually come in, they give us the permits to do the work, as well as field trials. We do field trials, and thereafter there are usually national performance trials and then variety release. So it is an integrated approach. We usually involve a lot of stakeholders in the development of a product. So usually the public may ask, what is the product? Do you have a product? No, we don't. We are doing research. We're doing the basic research, or the fundamental research. However, we need this research to be scaled so that it may be rolled out. But I know it takes time. It takes a lot of effort, and also trust. Trust from the public, because as you know, there are a lot of myths about this technology and misinformation. That's where I'm saying organizations like ISA, I really commend you guys for trying to put out factual information out there. It's a very noble cause, and it helps the researchers to scale their work from the laboratory to real life applications.
Wow, that's very elaborate. But also along that line, just shortly. Now, once you're finally done with the trials and everything, what happens once you give the farmer that seed that is probably resistant? Does it mean that Striga will now not continue to grow? Will Striga weed still grow but not affect? What happens? Does the prevalence of the Striga reduce? What happens?
As I mentioned, the word here to answer that question is management.
Management.
You're not entirely eradicating it.
Okay.
You're trying to manage or reduce the prevalence, so that the farmer may get something. Because if from literature, you may find that this particular parasite that we do study, and it usually causes yield losses. In form of percentages, it may be 20 to 100. 100 meaning total yield loss. So for instance, it was causing a yield loss of 80%. If you confer some resistance, let's say, if I'm being honest, maybe you reduce that frequency from 80 to 50. That's something.
Okay.
Yeah, and work in progress, and we are always learning. And I'm not saying that you just use one approach. I mentioned earlier that we use conventional approaches, such as improving soil fertility. There's intercropping. This is whereby, for instance, if you plant your maize, it's usually you are encouraged to mix it up with beans. So if you get a crop that you have improved it through genetic means, you can also apply these other methods, such as applying fertilizers. That is the classical one. Just apply fertilizer, because this parasite thrives in soils that have low fertility. Yes.
I get that. Well, we might not complete the discussion of witch weed today. And definitely you've said that's not a silver bullet. You have to use many other methods to try and reduce the prevalence of some of these weeds. But why would because it happens a lot, why would all these benefits that are conferred on smallholder farmers and everybody else by science create resistance. Why will, tell me from a point of view as a scientist, why would a solution that you're bringing to a farmer who is struggling to get yields be resisted even when it can be seen that it's worth even a try, even when they're not sure? So how does it happen that there's the resistance despite the potential benefits?
Nice observation and nice point. So I may say it comes down to the issue of what are you doing with my crop? You're developing a crop from the lab. I cannot trust you. You're a human being. Yeah. So you're modifying a plant, let's say. So there's that notion from the public and the masses, and you cannot beat up that notion. All you just need is public trust. And what you usually say that we have the necessary regulatory organizations in the country who check on what scientists or researchers do. For instance, the agricultural biotechnologists who use genetic modifications or genetic engineering, as well as the new technologies like genome editing to improve crops. So I can say my opinion on that. I don't want to say it's a fact. My opinion on that is that all the work that researchers do is highly checked. It's checked, and checked from the lab to the field trials to the national performance trials until when there's a variety release. And we have various organizations in the country who have a role to play before a crop is released for the masses. Similar to BT cotton, when it was released, it went through a lot of checks before releasing it. So I think the solution here, I'm not saying a solution, the way forward in here for this is to educate the masses. You educate them about these technologies. It is applied in other countries. For instance, the US, they have a lot of GM crops, as you may know. But it's good to educate the masses. I'm not saying it's something that can happen overnight or in the short term. It will take time to build the public trust, to understand, oh, these guys, they're researchers. They are one of our own. They are trying to help us. We have issues with yield caused by maybe high population increase. We need more food to feed the population. Issues of environmental constraints such as climate change. They are trying to tackle that by rolling out drought-tolerant, for instance, maize. So they should just understand these guys are trying to help us. Do we have the checks in place? Yeah, good. And having that objective information within the masses will greatly help in ensuring that all these products that we scientists, I'm saying we scientists because we are many working on different crops, very many different crops. We may be working on sorghum, maize, others on potatoes. It doesn't matter. It is for addressing the issue of food insecurity. So the end goal is what matters, but a good approach is communication. People should communicate with each other. Researchers, with the policymakers, with all the leaders, and as well as the general public. Communication and an understanding. And seeing is believing. As you may know, take people to the field, show them, here are the trials. They are performing. For instance, this particular crop is resistant to this pest. You see, it's not being affected. So it will take time, and I'm sure we have a long way to go, but we'll get there.
Nothing actually really beats evidence. I remember last month in the national dialogue, I think it was PS Prof. Shokat who said that the country should learn to kind of trust in its scientists, because these are people who went to school, got highly trained, and they're working for a result that is going to impact them as well, and their families as well, and the people they love. So I think it's also, if you realize, I don't know if you've read some book by Professor Calestus Juma, who speaks about tech and how tech was resisted in the past. Like people said when automobiles were introduced that unlike horses, they don't reproduce. So we are actually doing damage to cells. But coming now to you and doing all this science, where did it start for you? Did you grow up thinking, well, I want to go and knock off some genes? How
Not really, not really.
How did it start for you? Did you always want to be in STEM? And if in STEM, did you really think about biotech? Or did you even know about how did it start? Journey?
I won't say it was a choice. No, it just came by. For instance, if I may go back, I remember back in the days when I was in primary school, I think somewhere in class 6, we did an experiment on a potato, osmosis. It really intrigued me. Fast forward to maybe high school, and I love the sciences. I did all of them. I did biology, I did chemistry, I did physics. I did quite well in all of them. And when it was time to transition to university, I chose a course in science, specifically biochemistry. Yeah, it was quite something. At that time, I was just studying for the sake of studying. I usually told her, go to school, study, maybe you'll get a job. That was the idea. And that is the case nowadays, but I hope it is changing. Most people go to a profession or a career, a course for career purposes, but they are not looking towards that career aspect of that course. They're looking in terms of looking for a job. So after doing that, at that time, the idea of being in science had not come about. But after completing my undergraduate, I look, of course, classically, I looked for a job. It was challenging, I know. And of course, the jobs you get nowadays are not that enticing. So at that time, the importance of mentors now. I went back to school, not to school, I went back to my former university, had a conversation with one of my departmental lecturers, and they really encouraged me register for this course. That's not the MSc masters. That's when I started my biotechnology course. Of course, we did our coursework and so on, and then after that, that's when I answer your question now. That's when the desire to be in science came about. And after doing that, of course, I've mentioned about mentors. I got a really good mentor whom I'm working with at the moment. I'm in his lab, and that's when I decided, I really like science. That's when I started my project. What we have been talking about, parasitic plants specifically. And long story, I've been in parasitic plants for 10 years now.
Oh, okay.
Yes.
That's for some time.
Yeah, so I've done that. Of course, I graduated, and then I went into science communication for a short stint, I think 2 years. And then I decided, wow, I can really communicate, but I'm lacking in something. I need to finish the journey. That's when the idea of continuing with research now at maybe a PhD level, that's when the idea came about. And I've been doing that for the last 1 year now, still on parasitic plants. And I can say it is quite interesting because every day you get to learn. Because you think you know, but you don't know. And I usually encourage myself every morning when you get up. I usually have a quote: be there when the ball bounces. For instance, if you take a basketball and bounce it here, if it bounces, it comes up. So be there to catch it. If you're not there, you won't catch it. I use this example for all those guys. For instance, you just stay away from somewhere, you will not get that opportunity. Maybe that opportunity will come this particular day, but you are not there. And that particular opportunity can change your life.
Yes.
So I usually strive to learn every day, learn new skills. So as I said, from my previous research experience at the MSc level, I had not got all the necessary know-how or skills or techniques in a particular field, that is biotechnology. But nowadays, I'm learning every day, and it's quite interesting.
Okay.
Yeah, so I'll say truly I'm on the right track and continuing getting better and better in this particular field.
Yeah, as you get closer and closer to the serial killer. But at the same time, we had a discussion before, a slight discussion, and spoke about undergraduate students getting opportunities as well
Yes.
that probably you didn't
Yeah.
have at your time, or probably. So tell us a little bit more about that and how that prepares them for their futures, maybe in biotech.
Yeah. Of course, times are changing. For instance, when we were starting off ourselves, maybe we started at a later age. But nowadays, you get some curious young guys. For instance, in our lab, we have some young guys, quite interesting. They are open to learning, and so on. So as I said, I was not exposed to such aspects of this particular field of mine at an early age compared to them. Honestly, I can say I got exposed to, let's say, applying these techniques way later during my master's level. But you see now, we have some guys who get exposed at an undergraduate level, which is nice. So this is a rallying call to the young guys. Take the initiative. Stay curious. And the initiative here means that it should come from within. From the young guys, it doesn't matter if you have not completed your undergraduate, doesn't matter. Start early. Maybe you don't know. Maybe this is your calling. I'm not saying it is cast in stone that you should be a scientist, even if you're doing that particular scientific course. But start early. You never know. Maybe you're the person who will make a difference. You'll make a good innovation or a useful innovation. But start early. Have that initiative, and also seek out mentors. Mentors are very important. Mentors, I mean by experienced researchers. Even you may you may indulge them. You ask what is this? You just ask those questions. Don't be afraid. And one thing I usually say, don't be afraid of failure, because you may fail once, twice, and then you give up. So be persistent, and at the end of it all, things will turn out well.
Yeah.
Because in science, if I may add, in science you may run an experiment and then it fails. What do? Maybe you get disappointed. I usually tell people, if an experiment fails, go home, come back the next day, start it again. I usually say that. Don't, if it fails today, don't do it again. Come the next day, go and clear your head and come again. So back to the point, the young guys, please just start early and take the initiative. It's a beautiful, it's a noble discipline, that I may say, because we are addressing important issues in the society. I'm biased towards agriculture because that's I'm focusing on agricultural biotechnology, but also there's healthcare. There are people, scientists who are doing a good job or research in healthcare, trying to find solutions to healthcare problems. It doesn't matter which field you are, but the right cause is finding solutions. As you may know, finding solutions is the end thing now. Establish solutions to problems.
Yeah. Especially, the other day I was seeing a group of students, young students, maybe primary school level, being lined up to tell their teachers what they would want to be in future, and there was such a disconnect between what we used to say when we were kids versus now. I'm a beneficiary of the free primary education. Like, it was around that time when I was in primary school. So, and we can see the whole clamor there is now for constitutionalism across the continent. Young people, we have a lot of young energy. They went to school. What I can't be sure of is the career choices that were taken at the time. I saw kids the other day saying they all want to be YouTubers because, like you said, they are looking at the money. The general feeling, we've had this discussion here before because we were talking about women in STEM and everything else, is that there are not as many people who embraced STEM as one will think once they realize that there are so many people who went through school, especially like in Kenya, because of the free primary education program. So right now, the young kids might not have as many scientists among their older brothers and sisters to look up to, in spite of those older brothers and sisters being educated. I was also in a school where the three sciences were compulsory, but not very few people preferred to continue with science. So the young children probably don't have as many role models of our age or the older, like for that. So what will you tell this kid who probably will listen to you and think, okay, that's one scientist who is doing a very good job, and I know a few more, but they're not as many as they are saying. And as it stands right now, being a YouTuber is the in thing. What will you tell that kid who you feel should really focus on STEM?
Yeah, to be honest, I can say I will answer that in terms of a challenge, not a challenge. I will focus on the challenging aspect. I will say at the moment, not at the moment, a challenging aspect we have, for instance, in maybe African countries, is lack of capacity, but efforts are being put to improve that. So it's one thing to say, to go and tell a young person, go into this particular field, but they're not seeing the prospects going forward. So that is something that is lacking. I will answer that in the honest way possible. But yeah, taking the initiative also, I may answer that by taking the initiative, but I will say a call to action, especially towards the issue of lack of capacity. So you may find there's a huge difference between research done in Africa and that done in this other the first world countries. So the issue of funding is a problem, infrastructure, uh, lack of harmonization in regulations, and local leadership. So I will say, I will call to those responsible parties to have a good local leadership of researchers in the country, so that so that these young people may see these professions, the STEMs, the science, technology, engineering, and maths, as career choices that has good prospects heading into future. I would say not many people shy off the science courses. I would say that because you may find a lot of people drop by as you carry along from the undergraduate to the masters. Few people get to the end, and that's something that, for instance, our leaders in the country needs to address. Give science a chance, and maybe you never know. As we said initially, science provides solutions to the many problems in our communities and country as a whole. Healthcare, agriculture, and so on. Yeah. So I'll say give science a chance so that these young people may see these concepts as our profession as desirable. Yeah, that's the question.
But I'll keep wondering, really. I'm thinking like we see footballers and the insane amounts they make, of course, out there. And there was a running joke that the amount of money that someone like Lionel Messi makes, and I was to ask you your football team and how it's performing.
Dismally.
What team is that?
I am on sabbatical in terms of football, but Manchester United.
Normally Manchester United.
Yeah.
So if you ask a kid how much Bruno Fernandes is paid, or you tell a kid how much Bruno Fernandes is paid a day, an hour, a minute, versus probably some of the top-rated scientists, Nobel winners and stuff.
Yeah.
The thing is, or how much a musician makes, they end up thinking that probably it's going to be too little for too much, done. You're saving humanity here. You're trying to bring a situation of food security and everything. beyond now, those who are in power and those who can enabling the uptake of system by making it exciting and easy to pursue. What do you think about that? Or do you think it's going to come to a point where kids will look and think even monetarily it's rewarding enough to go do your master's, to go do your PhD in that very difficult STEM course, instead of just going to be a YouTuber or trying to be Lionel Messi?
When it comes to money stuff, it is an entirely different conversation. But I would say passion. If you're passionate about something, money doesn't matter. But as long as you get by, you live a good life. Those huge chunks of money, huge amounts of money, they're crazy, I must admit. But as long as you're living a good life,
That's it.
just be passionate about what you do. Yeah, as long as your life is okay.
Okay.
It doesn't. You don't need to compare your what you get
Yourself to Cristiano Ronaldo.
with those footballers.
Lamborghini.
Yeah, it's crazy.
It is. It is
It-
because you look at the monies, and I read a lot of science journals because, well, once you study a science course, your mind is fixed on seeing exactly what's happening out there. And I think these people are working on very, very difficult projects.
Yes.
And Lionel Messi is playing a game, and
Yeah.
you know,
Right now, maybe he's on holiday. I don't know.
they actually are. They've just been eliminated from the World
true.
Cup, so
I saw
definitely
that.
on holiday. I spoke to Professor Migisa Kaba. You might know Professor Migisa from Ethiopia, at the University of Addis, and he was telling me what you just said. It's about passion, and he also said it's about patriotism. He was telling me about why he didn't go and work out there, and he decided to just work in Ethiopia and in Africa in general. So he was telling me you have to be passionate and you have to be patriotic.
Yes. Homegrown solutions.
Yes, homegrown solutions.
You look at your community.
Yes.
Yeah. You see there are problems here and there. I'll give an example in healthcare. You may see problems regarding about malaria and so on. Many people are affected with malaria in those areas that. But you see, someone has grown in that environment. That person has seen the suffering. Maybe that particular researcher researching on malaria has been affected by malaria. So the person makes it his mission or her mission to try to provide solutions, even if it's the conventional methods that we're using, providing bed nets, sensitizing people. You see, that is a noble cause, providing solution. So that is where the passion comes in. And once you start seeing the results, you get huge satisfaction from your work. For instance, if I provide solutions to the farmers who does not get yield from his or her small piece of land, maybe that land, what that person gets from that land is the income is used to run a family setup. But if you provide solution to that, you will have educated the children, given them better healthcare. So generally, you have bettered their lives. So that's where the passion and satisfaction and the noble cause of of why we do what we do. Yes.
Those who used to take medicine in the past used to tell us medicine is a calling, just that, and they just expected us to interpret. Now, for your final, your parting shot,
Yes.
looking into that camera, what do you say?
Yeah. A parting shot, I would say, I'll just encourage people. If I may be biased towards research, those involved in research, please carry on. You never know. Maybe it may not seem like it right now, but at the very end, maybe you'll provide solutions to age-old problems, and keep on keeping on. I will say that. Yeah.
So, as Willie and his colleagues gang up to attack this serial killer, there's so much more that he represents or he advises. He's talking about not giving up. Come, do it again and again and again. Do it tired, do it, in all seasons. It's going to work out someday. You have to be there when the ball is bouncing. So he'll catch it, definitely. Last I checked, he was a fan of football. Now he seems to have switched to basketball because Man U is not performing very well. And at the same time, he speaks about passion, and you have to be really passionate about it. He speaks about resilience. He speaks about opportunities. He speaks about about trying to create homegrown solutions and getting the satisfaction of giving back to your society. Willie is doing an incredible job out there, and as a communicator, he's also helping us slay these dragons of misinformation and disinformation. And to again remind you that in August, between 26th and 28th, we'll be having the ABBC symposium in Lusaka, Zambia, where we shall be discussing possible solutions to this very, very big and venomous, gigantic kind of enemy that's been facing us for the longest time now. We keep the discussion ongoing here. Thank you very much, Willie, for joining us and for those incredibly insightful takes. And we will keep the discussion going on this. And Willie, just like he spoke about mentors, is I think available to mentor young and upcoming scientists and anybody else who might want to contact him. Is one of our partners. So thank you very much for joining us. This is the Africa Science Dialogue, and my name is Peter Theory. See you next time.